Hello friends. We said that coordinate geometry is the study of geometry by the use of algebra. So our objective in this chapter is to revisit the simple geometrical concepts by giving an algebraic take to it. Now since we studied about a point and how to represent the point algebraically as coordinates, let's move forward to study the basic or the simplest geometrical figure, a straight line. Now our main focus will be to represent this straight line algebraically, for which the concept of slope is the most essential. So in this video, let us learn about what a slope of a line is. Now we know that we can draw multiple lines in the coordinate plane and each one of them is different from the other in some way. So how do you differentiate one line from the other? Well, if you try to put this in words, one of the major differentiating factors is the orientation of a line in the coordinate plane. Well, the line can be horizontal, it can be inclined towards me, it can be vertical, or it can be inclined the other way. Now this orientation, or normally called the steepness of a line, can be understood as the slope of a line. But now the question is, how do we represent this steepness quantitatively using numbers? Well, the most common way to represent the steepness of a line is using the angle that the line makes with the x-axis. And we know that every line makes two angles with the x-axis, right? One with the positive direction and one with the negative direction. And both of these angles are supplementary and add to 180 degrees. But normally, the angle that is made with the positive direction is used to represent the orientation of a line, and this angle theta is called the inclination of a line. Well, if you see, if the line is horizontal, the inclination theta is 0. If the line is inclined towards me, the inclination theta is acute. If the line is vertical, the inclination is 90 degrees. And if the line is inclined the other way, then the inclination is obtuse. Right? So the inclination theta can range from 0 degrees all the way till 180 degrees. But this inclination is not called the slope of a line because we haven't introduced any algebra into this. So then what exactly is the slope of a line? Now suppose you have 2 points whose coordinates are known. By joining these 2 points and extending them, we get a straight line. Now say the inclination of the straight line is theta. Now the slope of a line, also called the gradient of a line, is defined using the coordinates of any 2 points in the coordinate plane. The best way to view this is as follows. If you travel from one point on the line to another point, then the slope or gradient of the line is defined as the amount of change in the y coordinates divided by the amount of change in the x coordinates. Well, delta x and delta y are just a fancy way to represent the amount of change in the x or y coordinates. Well, since we know 2 points on this line, let's start from the first point and travel along the line to the second point. Now the amount of change in the y coordinates is this vertical line segment y2 minus y1, and the amount of change in the x coordinates is the length of this horizontal segment, which is x2 minus x1. So the slope of the line is nothing but delta y by delta x, which is y2 minus y1 by x2 minus x1. Now there's something you need to know which is very interesting about a slope of a line. For a fixed straight line, the slope is always constant. Now you may wonder, why is this so? Well, you can see that you can kind of form a right angle triangle here. Now the angle in this right angle triangle is nothing but the inclination theta, because these are corresponding angles. And the opposite side to this angle is the length of this vertical line segment, which is y2 minus y1, or the change in y coordinates. And the length of the horizontal line segment is x2 minus x1, which is the change in the x coordinates. Right? So the tan of this angle theta is nothing but delta y by delta x, which is nothing but the slope. Right? So the slope of a line can also be written as the tan of the inclination. And since inclination is a fixed quantity for a particular straight line, the tan of that angle should be a fixed quantity, and hence the slope of a line is a constant. So we can say that there are 2 ways to view the concept of a slope. The first is when the coordinates of any 2 points on the straight line are given, then the slope of a line or the gradient of a line is defined as y2 minus y1 by x2 minus x1. And if the inclination of a line is provided without any information about the points on the line, then the slope of a line is defined as the tan of that inclination, which is tan theta. Right? So if the slope is positive, that means tan theta is positive, so theta is acute. And if the slope is negative, that means tan theta is negative, that means theta is obtuse. Right? So based on the value of the slope, you can kind of guess how the line can be oriented in the coordinate plane. Now from this algebraic definition of slope using the coordinates of any 2 points, we can observe that the slope is not defined, or it doesn't make sense when the denominator x2 minus x1 is 0. That means the change in x coordinates is 0. When do you think this will happen? Well, when the line is vertical, right? Now you can see that when a line is vertical, as you move along the line, the y coordinate is changing, but the x coordinate is constant, and hence the change in x coordinates is 0. So that means for vertical lines, the slope or the gradient is not defined. And this can also be made sense by using the other definition, which is slope is equal to tan theta. Right? For vertical lines, theta or the inclination is 90 degrees, and we know that tan 90 is not defined, right? So therefore, the slope of a vertical line is not defined. But what about a horizontal line? Now for a horizontal line, the x coordinate is changing, but the y coordinate is not changing. This is okay, right? Because we get the slope as 0. And this is obvious because a horizontal line doesn't have any steepness. It has absolutely 0 steepness, right? And hence its slope should be 0. So just remember that for horizontal lines, the slope is 0, and for vertical lines, the slope is not defined. But let's try to understand the concept of slope using an example. Well, here you have a straight line drawn on a graph, and our objective is to find the slope of this line. Well, if you know the inclination theta of this line, then the slope is nothing but the tan of that angle. You can use a protractor, find the angle theta and find the tan of that angle, and you'll get the slope. Also, you can find the slope algebraically if you know any 2 points on the straight line. Now by observation, we can spot 2 points on this line. One of them is 2,4 and the other one is 6,2. So the slope should be delta y by delta x, right? Now what is the change in the x coordinates? It is 6 minus 2, 4. And what is the change in the y coordinates? It's 2 minus 4 minus 2. So the slope should be delta y by delta x, which is minus 2 by 4, which is minus half. So therefore the slope of this line is minus half. Normally the slope of any line is denoted by the letter m. Now there's no reason as to why the letter m is used. Some English mathematician in the 19th century first started using this letter, and it's been followed since then, right? So therefore the slope of a line m here is minus half. Now we got the slope as a negative value. So what does it mean? That means the inclination should be obtuse, right? Which is very clear from this graph that the inclination is an obtuse angle. Now let's come to the most important question. Why is the slope of a line so important, and how can this be made use of? Why did we start the chapter of straight lines using this concept? Well, we'll try to answer these questions in the coming videos. So until then, keep learning and let us summarize. The angle made by any straight line with the positive direction of the x-axis is called the inclination of that line, generally denoted by theta. Hence, by definition, 0 less than or equal to theta less than or equal to 180. The slope, also called the gradient of any line, is a number that defines the steepness and orientation of a straight line. It is denoted by the letter m. The slope of a line is defined as the change in the y coordinates divided by the corresponding change in the x coordinate between two distinct points on the line. The slope m of a non-vertical line passing through the points x1, y1 and x2, y2 is given by m is equal to y2 minus y1 by x2 minus x1. The slope or gradient of a line can also be defined as the tan of the inclination theta. And by definition, slope of a horizontal line is 0 and slope of a vertical line is undefined.